I'm gonna need a cringy intro for these videos at some point, but how y'all doing? Okay. So today, as requested, I put the poll on my IG. It's not exactly a proof because I am using a problem and I am using a specific numbers with it, but it's pretty close enough. The actual proof for the reason why if you have one particle of certain mass hits another one of equal mass and it's an elastic collision and there's going to be an angle of 90 degrees in between. That one, if I were to use complete, like just variables, I'll have to use the law of cosines and this video is going to be like 20-30 minutes long. But this will be easier because I only have to use one trig identity, cosine squared x, sine squared x equals 1. But let's dive right in. So we have the 6 ball, it's a pool problem. We have the 6 ball traveling at an initial velocity of 10 meters per second. It hits the 8 ball, and then the 8 ball goes off at some final speed 30 degrees above the horizontal, and then the 6 ball traveling down with some final speed and an angle of theta from the horizontal. So if you're in physics C, you already know this is going to be 60, but we're going to do it a little bit rigorously today. So the masses are equal, so I'm going to say m6 is equal to m8, and it's an elastic collision. Okay, so what does this mean? This means the kinetic energy of the system is conserved, so we can write this as k naught is equal to k final. So first, at the beginning, we only have one kinetic energy. That is this boy's kinetic energy right here, the 6 ball. So 1/2 mv6 naught squared. This one's at rest, so we don't have to write that down. As if you're not moving, then you have no kinetic energy. And then at the end, we have this boy right here. So 1/2 mv8 final squared, and we also have the 6 ball's final velocity. So 1/2 mv6 final squared. Note that I didn't break it up into components because this statement holds for resultant velocities. If you want, I could break it up into components because it's actually pretty cool. I didn't know conservation of energy could be broken up into the x and y plane dimensions respectively. But I found that out doing quests when I couldn't solve a problem. But like basically these final velocities are the resultant velocities, and it's gonna make it easier. I could break it up, like I said, into components, but I'm not gonna do that. So what are things we can eliminate? So we can multiply everything by 2 to get rid of the 1/2. And I said both of them are of equal mass, so we can kill the m's as well. So we get that v6 naught squared is equal to v8 final squared plus v6 final squared. So this is going to be helpful later on when the math gets ugly. So now let's take a look at the momentum. So additionally, a reason why you don't have to break this up into components because kinetic energy is a scalar. Momentum is a vector, however, so that means we need to break it down into its components to analyze it. So let's take a look at the x direction first. So p naught in the x is equal to p final in the x, right? For any isolated system such that the net external impulse is 0, momentum is conserved, okay? So that's what this statement says. So let's take a look at which object has momentum initially. So that's only the 6 ball, right? So m v6 naught, and then that guy's at rest, so he has no momentum, is equal to, now how about at the end? We have the 8 ball has momentum, so mv8 final, and now he's at a 30-degree angle above the horizontal, and the x component of that is going to be dealing with, since it's like this, right? So that is v8 final. Let's just call it vx uy. It's going to be dealing with the cosine, correct? You can run through the trig. I assume it's trivial to you at this point, but if you have a setup such that it looks like this, 30 degrees above the horizontal, the x component is going to be the cosine of 30. And then at the end, we also have this v6 final, so plus mv6 final and cosine of theta. We don't know what it is. So what can we do here to clean up? I know, sorry, I didn't give myself enough space, but we can kill the m's because they're all the same. So divide everything by m. So v6 naught is equal to v8 final cosine of 30 plus v8 final, sorry, cosine of theta. Cosine of 30 is nothing but radical 3 over 2. So let's rewrite that. This is v8 final radical 3 over 2 plus v6 final cosine of theta. Now, as I said earlier, we're going to be using this identity to solve this problem. So what I'm going to do is I'm going to isolate the cosine term on this side and then the sine term on this side, and then plug it in here and do a lot of algebra until I want to die because the algebra is quite a bit of algebra, not going to lie. So basically we're going to isolate cosine of theta here first, right? So radical 3 over 2 v8 final, and then divide by v6 final to isolate cosine of theta. Now let's look in the x. I mean, not in the x, in the y. I just woke up. I'm sorry. Okay, so p naught into y is equal to p final into y. This thing is only moving in the x plane, so it has no velocity in the y, thus its momentum in the y is 0. And this is at rest, so there is no initial momentum in the beginning in the y direction. And then at the end, we have this guy, right? So m v8 final, now sine of 30, plus m v6 final sine of theta. Now, I'm going to do sign change here for a second because this theta, with respect to the horizontal, if you do like a nice little reference angle thing, this is basically going to be, the sign of this is, it's going to be a negative value because the opposite side is down. So using the property such that sine is a odd function, I can bring the negative theta outside. So I'm going to rewrite this as a negative because obviously and intuitively the y component is going down. So that's another way of going about it. So we have mv8 final sine 30 minus mv6 final sine of theta. And so you can add this to both sides. So we get, and let me as well get rid of the m. So we're going to divide by m and add 6 to this side, v6 final to this side. So there we go. And sine of 30 is nothing but 1/2. So, and well, at the same time, I'm going to divide by v6 final to isolate the sine theta. So this is v8 final. So sine of 30 is 1/2, so I put a 2 on the bottom, and then v6 final right there. So that is our sine theta term isolated. So this part is going to be quite messy. So I am first going to rewrite everything and apply the identity, and then we'll do some algebra. Okay, so I rewrote the equations we did in our little physics setup over here. Now we're just going to do some math, right? So we have the identity cosine squared of theta plus sine squared of theta is equal to 1. The unit circle, thank God. I might actually do a derivation for this as well. Yeah, I'll probably do that. And as long with the 1 plus tangent, so you can square blah, blah, blah. So anyways, so we're going to plug this in first, right? This guy is going to be used for later, and you'll see why. So I'm going to plug him in. So we have v6 naught minus radical 3 over 2 v8 final over v6 final, whole thing squared, plus, that's a 2, sorry, v8 final over 2 v6 final squared is equal to 1. This is going to be quite ugly, so I'm going to do this step by step here. So I'm going to square the bottom first, and I'll put this in parentheses just so to maintain my order of operations. So I square the bottom, then here I square everything. That's fine, don't have to do any binomial stuff. Okay, what can I do? So I'm going to multiply both sides by v6 final squared before I expand this, because this is going to be quite messy. V final squared plus v8 final squared over 4 is nothing but v6 final squared. And then finally, I'm going to expand this. So this will be v6 final squared, so minus 2, right? If you do this, x plus y whole thing squared is x squared plus 2xy plus y squared, so I'm just using that, and then plus, so square this, that just becomes 3 over 4 v8 squared plus v8 squared, voice crack, is equal to, dang, okay, let me just check if I did this right. So square that, multiply these two things together, put a 2 in front, and then, yep, okay, we are good. We are good, we are good, we are good. So what can we do here? So I noticed there's a 3/4 v8 final squared and there's a 1/4 v8 final squared, so I can just add them together to get one v8 final squared. So this is, I'm going to multiply the 2 in here as well. So sorry if this is like kind of hand wavy, but like this is just straight up math. So it's not the physics. We do physics here, not math. And then we have v8 final squared is equal to v6 final squared. And now we have 3 unknowns here. We do know v6 naught. This is actually 10. Let me just rewrite this as 10 right there. So we just have 2 unknowns, and this is also 10 squared because that's v6 naught. So 10 squared. Clean this up a second just to collect myself. So 10 radical 3 v8 final plus v8 final squared is equal to v6 final squared. Now, this is a choice. You can either make it extremely disgusting for yourself and solve for v8 final here and plug it in right there. That's going to be really ugly. Instead, I'm going to solve for v6 final squared. Because, so let me just rewrite this such that we solve for v6 final squared. So v6 naught squared minus v8 final squared is equal to v6 final squared. And as I said earlier, v6 naught is 10. So I can rewrite this as 100. Okay, and now let's plug in. So 100 minus 10 radical 3 v8 final plus v8 final squared is equal to 100 minus v8 final squared. There's 100 on both sides. Subtracting the 100 from both sides, we get that can go away. And then now we have negative 10 radical 3 v8 final plus v8 final squared is equal to negative v8 final squared. So what can we do here? I'm going to subtract v8 final squared from both sides. So here. And, sorry, we rewind it a little bit. And then we can divide both sides by v8 final. And there we go. So v8 final is nothing other than 5 radical 3. Oh yeah, just to clarify for the mathematicians out there, it's impossible that v8 final is 0, so we can perform that operation right there without dividing by 0. So that is our first answer right there. So we know that 100, using this guy right here, let me just draw an arrow, minus, so now it's 5 radical 3 squared is equal to v6 final squared. And yeah, if we 100 minus, what is that? So square that, that's 25, square that, that's 3, 25 times 3, that's that, and we can rewrite that as 25, take the square root, and we get v6 final is nothing other than 5 meters per second. Okay, and then finally we can plug in these two numbers in here to solve for sine of theta. So we have 5 radical 3 over 2, and now this is 5, is equal to sine of theta. So, oh, very nice. So we get the inverse sine of 3/2 is nothing other than theta. So the 5's cancel, and we have 3/2 is equal to sine theta. So what angle, basically the statement means what angle will give me a value of 3/2 if I plug it into a sine function. Well, that is going to be, what is my pre-cal that I didn't take? That is going to be pi over 3, which is 60 degrees. So, and thus we have kind of proven-ish that an elastic collision between two masses of equal mass, when one of them is at rest, is going to yield a 90-degree angle between them. So that is it. As you can see, it's a lot of math. I can kind of see why Fox didn't want to do it, but I did look up the one where you use only variables, and it's like, it's so mathy, dude. My goodness, it's so rigorous, and like this board, I'm gonna need like 3 boards to do it. And plus, it's law of cosines. No one wants that. That is it. 60 degrees, my guys. Hope you enjoyed.